Hello, Mr. Ryan. Are you right? Yeah? Yeah. So look, we are given a list of sorted numbers. So these numbers are sorted in long descending order, ascending, right? Yeah. So we want to return a copy of the squares of this list. For example, the square of each number, right? So look, this one is squares of it, which is what?
25.
25. And this one?
4.
This one?
0. 1. 49.
We're done. Okay, but we want to return square in sorted as well.
0, 1, 4, 25, 49. 0, 1, 4, 25, 20.
We're done. Okay, so how can we do it? Simple. We want to square each number to the power of 2. To the power,
I'm thinking of sorting.
Sorting, yeah, we're done sorting, yeah. So we go through each number, we square it, yeah. We square it, and we just sort it, yeah. That's a very obvious way. That's very obvious way. Look, how do we do it? Look. So
we could look at
what?
We could go on the shops and look for a timetable, and then look at each timetable found on it, and then just do and sort it. Done.
Okay, so you're saying that, but this timetable could be very big, right? Yeah. Because these numbers are arbitrary, so how can you find it that numbers in the timetable? So we are not talking about a few numbers like in the range,
do
right?
Maths,
Yeah,
and then sort it.
Yeah, exactly. So
And then done.
wow, that's an easy question, yeah.
What
So
am I
okay,
doing?
so look,
I'm doing a good job.
square. So do the math. That's what you say math, and then sort. Yeah. Okay. So 2 steps. Square and sort. Okay, let's just quickly write it. Okay, so it should be very easy. Okay,
I'm definitely not done.
okay. So let's do this. Look, define square of list, and then we given list numbers. So look, answer equals empty list.
Yeah. Yes.
Yeah. So we go through each number for I in numbers. So answer dot append what? Append what? I square. How do we calculate the square? How do we calculate a to the power
Maths.
of 2 in Python? How do we do this in Python?
A times A.
We're done. N
A to the power of A. Or power A B.
power a2, yeah? Or a star 2, yeah? Remember this syntax, yeah? Okay, so I times I. Okay, let's do it. And then we just return sorted answer, yeah? We can do this sorted answer, or we can do this answer dot sort in the front, and then we return answer. Both are okay. So the thing is that we can change this to a better syntax, yeah? Better. How do we do this? Return. We can just return one line, yeah? Return sorted x times x for x in numbers, right? Look, this is one line, yeah? Or we can do this another one using the map function. Return sorted map. The first function is the map. The first parameter of the map function is the function, yeah? So we can pass lambda. Lambda is a short function x to the power of 2. And then the second parameter numbers. This is okay, right?
Yes.
What's the time complexity?
N log n.
We're done because we have n numbers, yeah? We have n numbers, yeah?
Yeah.
Okay, so we can do in on time. So if on time. So how can we do this on time? The thing is that so what's the thing? What the thing is that the original list is already sorted, yeah? It's already sorted. So we want to make use of that. Look, -5. What? -2, 0, 1, 7, right? So we want to, this is already sorted. Yeah. So can we tell, the thing is that the minus, you're not sure which one is bigger, right? Look.
I am.
Yes.
That one's bigger because I have brain.
No, which one is bigger?
That one's bigger.
Square, I mean the square. This one is bigger, yeah? So look. Okay,
I have brain.
Okay, so let's say I have a 2-pointer, okay? Yeah? So because the largest one, we can go through the largest one we can fill the array. This is the answer, yeah? This is the answer, which is the sorted from the smallest squares to the largest square, right? So this one should be the largest one. It could be only 2 cases. Either you take this one or take this one. But we are sure this is bigger, right? 7 to the power of 2 is 49. This to the power is 25. So this is bigger, right? Yeah, so I take this, I put it here 49. And now, minus 5 and 1, which one is bigger? Come on. Minus 1 and 5, which one is bigger? To the power of 2. Minus 5. Okay, so I take this one and put it here 25. Okay, and then here, which one is bigger? Minus 2, 1.
Minus 2.
Okay, and then I square it.
What?
Put it here.
0.
Yeah, you see how do you call this diagram? I have a 2 pointer.
Yeah, 2 pointers.
2 pointer thing. Yeah, exactly. Yeah.
It's
Got
called a
it.
2 pointer ding. I have 2 pointers.
Okay, so what's the time complexity if you look at this way? I mean, what's the time complexity? Each one where the O and linear. Yeah, O and linear.
Yeah, that's
So
what
which one is bigger? The previous one, the sorting, O and log n. Which one is bigger? Which one is better? O n or O and log n? Which one is better?
Owen again.
Huh? O n obviously.
Because I have brain.
Okay. Let's implement this 2 pointer thing, okay? And then that'll be, okay? Come on.
And you're definitely going to give us another question.
No. Define. Very good. Hey, too noisy. Square.
Hey.
List the numbers. Square list. Okay. Okay, now n equals the length nums. The left pointer equals 0. The right pointer equals n minus 1. And then we also need a pointer to point to the location where we store the answer, right? The numbers in the answer. Let's call it, I don't know, I equals R, right? Okay, so while L is smaller, what? Come on.
L is smaller than...
No. Why?
Me!
So we are not, actually we can do this I, why I is bigger or equal than 0, right? Yeah, this is the index. Then we check. How do we check which one is bigger? We can do this absolute value, yeah? So look, x squared, x to the power 2 equals this to the power of 2, right? Yeah. What's this? This absolute value, which is ABS, the distance, yeah? Yeah, got it? So if ABS nums L bigger than ABS, bigger or equal, nums R, right? So we take the left one, right? Because the square will be bigger. So we take the left one, then we can do what? So the answer, okay, so we need to have an answer. Answer equals, let's allocate it, n. Okay, this needs to go to the front. We have an answer array which originally is all 0, okay? It doesn't matter which value is it, as long as we're going to override, update it later, okay? So answer I equals num L times 2, right? To the power of 2, and then L plus equal 1. Else answer I equal, then we take the number on the right, num R times 2, and then R minus equal 1, and then return answer, yeah? That'll be, yeah? Okay? Yeah? The time complexity, we talk about the time complexity is O(n), yeah? O(n), okay. Look, okay, so there's one thing missing is I. We need to I minus equal 1, because every time we choose a number, we need to move the pointer I to the left, right? So at the last, we are going to have these n numbers, because I originally equals to the n minus 1, and then when it reaches to 0, there will be exactly n numbers. Okay? Yeah? Do you see how this works?
Yeah.
Yeah, okay. So what have we learned today so far? So the naive solution would be just do the math, like you said, do the math and sort it.
Yeah.
No, not a big deal, yeah, not a fancy thing, yeah. Everybody could think it, yeah. Everybody can think it, yeah.
Hello, brain.
Yeah, but let's go to take O and log n because the sorting, right? That's not sorting. But this one is a better approach. Why is that? Because we're making use of the fact that the original array is already sorted. So if it's sorted, every time we take a number, we want to find the largest. We want to find the largest square. Yeah, it can only be in two numbers, on the left, or the smallest, or the right. the biggest, right? So we have 2 pointers. We pick one, which is going to give us the largest square, and then we move the pointer, right? Got it? Yeah. So we always fill the square largest the square number squared from largest to smallest, right? This is what the I is for. And the time complexity is O(n) because each number is visited exactly once. 2 pointer thing, and we are not sorting. Yeah, and that give us this better performance for this echo. Okay. Yeah, that will be it for today. Bye bye. Bye.